Hello everyone, this video covers section 10.4. The topics covered are how to find the area and arc length in polar coordinates. We did this already in Cartesian coordinates and also in parametric coordinates. Now we're just gonna do it using polar coordinates. So here usually the tricky part is to find the limits of integration. So before you try to find the area, make sure you integrate that you have a graph first, then you just integrate. Also, if you have a graph in calculator, make sure you use it so you can check that the graph is correct. Here we need the domain, so let's say that theta goes from pi over 2 to pi. So let's just plug in a few points. So we're gonna find the graph the long way, which is just plugging values, and then we do the graph, and from there we find the area. Again, if you have a graphing calculator, you can just use it to graph the equation. Now, many of these shapes repeat over and over, so it's a good idea to make a connection on how like something like this will look like and so forth. All right, so now the points you should pick are pi over 2, pi, and so forth, because those are the exact values for those. So let's say that we start with, if theta is 0, remember cosine of 0 is 1, so 2 plus 1 is 3, so this will be 3. Then the next one will be pi over 2. Remember cosine of pi over 2 is 0, so 0 plus 2 will give you 2. Then pi, cosine of pi is -1, so in this case this will be 2 minus 1, which will give you 1. Remember this was 2 plus 0, and this was 2 plus 1. And then you need 3 pi over 2. Remember the cosine of 3 pi over 2 is again 0, so this will be just 2. And if you want to, you can also add 2 pi, which remember is the same value of this one, which will give you 3. Okay, so now let's plug in the points. The first one is 0, 3, so theta is 0, which is this line, and the radius is 3. So let's say this is 1, 2, and 3, so it will be here. The second one is pi over 2 and 2, so this is 1, 2, so it will be here. The third one will be pi and 1, so this is pi and 1 is here. And then 3 pi over 2, remember this is the line 3 pi over 2, and this will be 2, so this is 1, this is 2, so it will be here. And then obviously 2 pi will give you 3 again. Okay, so the graph looks something like this. Now they are asking you to find the area between pi over 2, which is this, and pi, which is this. So this is the area you're trying to find. Okay, so all you have to do is use the formula and also use the limits of integration, which in this case they are given. So for the area, remember it's equals to the integral, in this case will be from pi over 2 to pi of 1/2 r squared d theta. So in our case, this will be 1/2 the integral from pi over 2 to pi of 2 plus cosine theta squared d theta. If you expand this, you'll end up with, this will give you 4 plus 4 cosine theta plus cosine squared theta. Okay. So in this case, this will be 1/2 the integral from pi over 2 to pi, and then this will be 4 plus 4 cosine theta plus cosine square of theta, d theta, the whole thing. Now, if you distribute, this is just the integral from pi over 2 to pi of 2. That will be the first part, which is this. and then plus 2 cosine theta, and then finally plus 1/2 the integral from pi over 2 to pi of cosine squared theta d theta. Now remember the cosine squared is one of the identities we used before. Cosine squared theta is equals to 1 plus 2 cosine theta, 1 cosine 2 theta divided by 2. Alright, so therefore the integral of this one should be easy. This will be 2 pi minus pi over 2. Then the integral of cosine is sine, so it will be 2 sine theta from pi over 2 to pi. And then finally the 1/2. So notice that if you integrate both sides, this will be 1/2 theta plus 1/4 cosine 2 theta. Okay, we have integrated this multiple times. So this will be times 1/2 theta plus 1/4 cosine 2 theta, and also from pi over 2 to pi. So then just plug in the limits of integration, and whatever you get, that's the answer. Now the next question is actually asking you this. The question says find the area of one loop of this function. Okay. So the first thing you do is you can graph this. Now notice, this is going to be very useful. If you have sine, and this is add number and then theta, and this thing applies to cosine 2 add number and theta. So this will have add loops, like an odd number of loops. But if this is even, same thing applies to cosine. If it is even theta, then the number of loops is twice the number. So it's twice. Okay, so for example, in this case, this means this has five loops. But if it was, let's say, sine of 6 theta, then it will have 12 loops. Okay? Now the easiest way to find a loop is, remember that sine is a periodic function. Okay, remember that sine does this. So it repeats every 2 pi. So this is 0 to pi. This is pi. So these are the 5 points that we've been using so far. So you want to get to 0, you start here and you get to pi again. So that's one way to do the graph. Okay? But this is what I mean. So if we do a graph, you can also use the graphing calculator again. So if this is 0, well, this will be 2 times sine of 0, which obviously is 0. Okay? So then the next value you should pick is whatever is going to give you pi over 2. But to get pi over 2, well, that means you need phi theta to be pi over 2, which means theta is equals to pi over 10. This is pretty much the same technique you use in precalculus. So if this is pi over 10, then this will be 2 sine of phi times pi over 10, which is, again, this is just pi over 2. So it will be 2 times sine of pi over 2. Sine of pi over 2 is 1. So therefore, this will give you 2. Okay? So therefore, you start here in 0. And then at pi over 10. Now, pi over 10 is somewhere here. So let's say this is 1, this is 2. Actually, pi over 10 is around 15 degrees. So the graph will look this, go to 2. It's a different color. Go to 2. And then the next one, it will be pi. Well, now you need phi theta is equals to pi, which means theta is equals to pi over 5. So this is pi over 5. This will give you 0. So this will go down. So that will be one loop. Remember that this one has actually 5 loops, okay? So you will need to like more points to see the whole graph, but in this case it's just asking you for one loop, and this will give you therefore the limits of integration. So in this case the area therefore is going to be the integral from 0 to pi over 5. So remember, this is the second value we use, pi over 5 to get 0. And then this will be 1/2, the same formula of 2 sine phi theta squared d theta. So then you distribute, notice that 2 squared is 4, so times 1/2 will give you 2, so it will be 2, the integral from 0 to pi over 5. This will be sine square of phi theta d theta. Again, we have used this identity multiple times. Remember, sine square of theta is equals to 1 minus cosine 2 theta over 2. So in our case, this will be the integral from 0 to pi over 5, and then this will be 1/2 of 1 minus sine 10 theta divided by 2. Well, you already have the divided by 2 in here, so it's like this, the theta. So in this case, the 2's will cancel, and this will be the integral from 0 to pi over 5 of 1, or let's just say the theta, minus the integral from 0 to pi over 5 of sine theta, sine 10 theta d theta. And then the integral of this is just theta from 0 to pi over 5. And then the integral of sine is minus cosine, so it will be plus cosine 10 theta divided by 10 from 0 to pi over 5. So here we'll have pi over 5 minus 0, and then 1/10 cosine of pi over 5, that will give you, so 10 times pi over 5 is 2 pi, cosine of 2 pi is 1, and cosine of 0 is also 1, so this will cancel, so this will just be pi over 5. Now the next two problems are the hardest ones, because the first two were what you did like in calculus 1, where you only have one function. Now the next two examples is like what we did at the beginning of this class, when you had to find the area between two graphs. So it's the same idea, but now it will be in polar coordinates. Okay. So here you have two functions, r is equals to 3 sine theta, and r is equals to 2 minus sine theta. So let's start with the first one. So again, remember, this is theta, this is r. So if this is 0, this will be 0. You should check these values. If this is pi over 2, this is 3. If this is pi, this is 0. And if this is 3 pi over 2, this is negative 3. So if we do the graph of the first one, so 0, 0 is right here. And then pi over 2 will give you 3. So this is 1, 2, 3. Now pi, which is right here, it will give you 0, which is this value again. And then 3 pi over 2 is minus 3, which notices this value. We talked about this before. This is actually a circle. Okay. And the circle looks like this. I mean, I'm not the best drawing circles, but let's see something that looks like. Try one more time. This. I mean, that's a pretty ugly circle, but that's what it's supposed to be. So that's a circle. We actually did this in the previous section in 10.3, where we showed that this was the equation for a circle. And then we graphed something like this in the previous example. But if we plug it points again, this is theta, and this is r, this is 0, this is 2, pi over 2, this is 1, pi, this will give you 2, and 3 pi over 2, it will give you 3 again. So the graph will look like this. This will be 1 for pi over 2. 0 actually gives you 2. Pi also gives you 2. And 3 pi over 2 gives you 3. So this is 1, 2, 3. Therefore the graph looks like this. Okay. And clearly you can see that this intersects here and intersects there. And this one says find the area of the region that lies inside the first curve but outside the second one. So it's technically asking you to find this area now, right here. Notice that this is symmetrical, meaning that this area is the same as this area. Okay. And you need to figure out first where they intersect, just like we did in section 6 or in chapter 6, where they give you two graphs and you need to find the intersection. So to find the intersection, remember what we did before, you set the two equations equals to each other. So you have 3 sine theta, that's the circle, and then the other equation is this. So from here you have 4 sine theta is equals to 2, or sine theta is equals to 1/2. So that means that theta has two solutions, pi over 6. So that means this is going to be pi over 6. Okay. Or the second solution is 5 pi over 6, which means now this one is 5 pi over 6. All right, so let's try one more. So first, let's graph this one. Same thing. You have theta r. If this is 0, it will give you 2. If this is pi over 2, this will give you 1. If this is pi, it will give you 0. And if this is 3 pi over 2, this will give you 1. So for the first one, it will be 0, 2, which is right here. Then pi over 2 and 1. And then pi will give you again 0. And then 3 pi over 2 will give you 1. Now the graph for this one actually looks like this, so you may need to plug in more points to see why, but this is exactly how it looks. Okay. And then if we do the same for the second one, this is theta, this is r. So this will be 1 minus cosine theta. So if this is 0, this will give you 1. If this is pi over 2, this will give you, actually if theta is 0, this will give you 0, because cosine of pi is 1. If this is pi over 2, this will give you 1. If this is pi, this will give you now 2, because this will be 1 minus 1. And if this is 3 pi over 2, this will give you 1 again. So the point will be the following. You have 0, 0 again, pi over 2, 1, which is this point again, pi and 2, so now it will be 1, 2, and then 3 pi over 2 and 1, which is here. So now notice the graph is technically the same, but now it's in the opposite direction. So the graph looks like this. And notice, I mean, I didn't do the best job graphing this, but technically you have the same thing 4 times. 1, 2, 3, and 4. Okay. So all you have to do is find one of the areas and multiply by 4 by symmetry. Remember that this one is 1 plus cosine theta. Well, this one is 1 minus cosine theta. Okay. Therefore, the area is going to be 4. Now, which one you're going to pick? Well, the easiest one to pick is this one. Look. In this case, because this is the only graph is not intersecting with anything, so you don't have to subtract anything from the other one. Well, if you pick this one, you may have to subtract this from here. So here, notice that this graph starts in 0 and in pi over 2 you get this. So we're gonna go with the green part. So if we do that, this will be the integral from 0 to pi over 2. Remember the 4 is because you have 4 pieces that are symmetrical. And this will be 1 minus cosine theta squared d theta. Okay? And we have seen this function like 100 times by now. Also remember you need to have the 1/2 in there. That's the area formula. The 1/2 and the 4 gives you 2. This is the integral from 0 to pi over 2 of 1 minus 2 cosine theta plus cosine squared theta d theta. Using the same identity we did before, this will be 2. The integral of this will be theta. Then this is minus 2 sine theta. And we integrate this part. And remember this one was 1 plus cosine 2 theta over 2. So this will give you 1/2 theta. And this will give you 1/4 sine 2 theta. And all of this will go from 0 to pi over 2. And that will be the area. So notice that all the examples we did before was to find the area. The last example we'll do is how to find the arc length using polar coordinates. Now this is the formula for the arc length. And by now this will be the third formula. Remember you have one for Cartesian coordinates and one for polar coordinates. So in this case the value for r is 2 cosine theta, which remember this is technically a circle. You graph it, but you only go from 0 to pi, so those are the limits. So here we have the following: dr d theta, because we need that for this, is going to be equals to minus 2 sine theta. So notice that if you square that, should be no mystery. This is just 4 sine squared theta. Okay? So therefore this implies that r squared plus the derivative with respect to theta squared is going to be 4 cosine squared theta plus 4 sine squared theta, which is just 4 times 1, or just 4. Right? So therefore the arc length, it will be the integral from 0 to pi of the square root of 4 d theta, which is equals to 2 pi, or is equals to, okay, let me show the step, to the integral from 0 to pi of 2 theta. Well, this is 2 theta from 0 to pi, which is 2 pi. As you can see, this was pretty simple. So the level of difficulty for this problem obviously is going to depend on what kind of functions you have. As you can see, there is nothing easy to integrate in a constant. So if this function is a little more tricky, then you may have to use integration by parts or trig substitution or something like that. But as you can see, the most common identity is the sine square plus cosine square identities. And that's it.